Stop scrolling for a second. What if you could improve your SQL skills, solve real-world interview style challenges, build projects for your portfolio, and earn certificates, all from a single 24-day SQL challenge organized by Interview Master? In part 1 of this series, we're able to conquer from day 1 to day 6 of the SQL Advent Calendar. Today, we are taking things up a bit as we tackle from day 7 to day 12, solving life every challenge from scratch to finish and breaking down the logic behind every solution. So if you are new here, if you are serious about becoming a data analyst, about learning SQL, about strengthening your skills and preparing yourself for interview, subscribe to this channel, drop a like, turn on the notification so that you stay abreast when I drop the remaining part of this video. Check out the previous video because this series is designed to help you think like a professional SQL developer and solve problems with confidence. Before we get started, let me know in the comments which challenge from part 1 was your favorite and which SQL concept did you learn, and if you are following along with the challenge, type day 7 ready in the comments so I will know you are part of the SQL Advent Calendar journey. So now let's get right in.
Okay, this is day 7 and we have a question: snowflake type counts. Frosty wants to know how many unique snowflakes types were recorded on the December 24th, 2025 storm. Can you help him? Yes, we can. Okay, first of all, I'm just going to view what I have on my page. Let's select star all. Now let's check out this. Okay, as you can see, we have the ID, we have this flake type, then we have the fall time, right? So we're working on fall time that falls on the 24th of December. So we can see several. So another thing is we have time here. So this is a date time. So that's why we will need to have a check. We have a distinct count for date type, then have a check for the fall time within a range. So let's have that here. So first of all, I'm going to count. I want to count, let's put in a bracket, the distinct flake type, right? So let's see what this gives us 8, right? So this is all the distinct flake type. So let's give this a title of unique snowflake type. So from this, so I'll have a check where the fall time is greater than or equal to. Now I'm going to put the date state in double quotes. So I have 2025, the month is 12, the day is 24, right? Then I'll have and fall time is less than. This is just to ensure that we have accurate figure. So let's run this code. Unique snowflakes type. So I think with this we're able to correctly evaluate how many unique snowflake type were recorded on December 24th storm. So we'll move to day 8. Okay, welcome to day 8. So for this class we have a question: storage room inventory. It says Mrs. Cloud is organizing the holiday storage room and wants a single list of all decorations, both Christmas tree and light sets. Write a query that combines both tables and include each items and name category. Okay, this is looking more like a union. So let's check what we have for each of the tables. Let's check the storage tree. So we'll see the item name and the category. Category is all trees, then the type of tree. So let's check for the lights. Okay, the category is light and we see different kinds of lights. So basically all we need to do is just to join these two tables. So like I said, categorically say we should combine both tables and include item names and category. So I'm going to explicitly state item name, then category. Let's start with the storage tree first. So I could just bring this down. So let's check this out. So combining it, you'll see that we have the full list of all our item, just as Miss Claus wants. So let's run this. I will say that it is correct. Good. So we're done with day 8. Moving to day 9. Okay, this is day 9. We have a tinsel and lights combination challenge. So the ifs are testing new tinsel lights combination to find the next big holiday trend. Write a query to generate every possible pairing of tinsel color and light color. Include in your output a column that combines the two values separated with a dash. Isn't that interesting? Okay, so that is looking like a cross join, because the cross join actually returns every possible value from two tables. So if I have 2 rows from the tinsel color and have 2 rows from the light color, I'll be having a total, when I cross join them together, I'll have a total of 4. That means every possible pairing of the two tables. So let's start writing a code. So first of all, let's check out what we have in our table. Okay, we can see the colors we have: silver, gold, red, blue, green, and all of that. So let's check out the lights color. Okay, so we have this also. So let's do a cross join. So first of all, I want to have, for the tinsel, I will call it a T dots color. So let's check what we have here. So having joined the whole table, so we see that we have 1 row. So the next row we want to have is the concatenation, joining, like what we say, combine the two values separated with a dash. So we're going to use a concatenate here. So as you can see, we are combining the tinsel color name with the dash and the light color name. So let's check what we have here. Good. So we will see that we already have cross filtered and combined every possible pairing of the tinsel color and the light color. Right, so let's run our code and see. So that's correct. That's correct. So we'll move to day 10. Now for day 10, we have a cookie factory oven efficiency. So we have the question saying, in the holiday cookie factory, workers are measuring how efficient each oven is. Can you find the average baking time per oven rounded to 1 decimal place? So this is still the beginner level, so let's just get right in. So first of all, I want to check over what I have on the table. As you run this code, I will have an idea of all I have. So basically, I can see my batch ID and the oven ID and the baking time minutes. So we're looking at getting the average baking time per oven. So per oven, I'm just going to get the oven ID, right? Then I'm going to get average. Now if I should run this alone, it works, but I'll need to group by oven ID, right? So let's check this out. Good. Before, it gave me the overall average baking time. Now that worked because of we're using the SQLite. If we're using the Postgres, it wouldn't have worked. So we needed to add it group by. So one other thing that was we were asked to do was to round it up to 1 decimal place. So I'm just going to add up the round. Now this should work. Good. So we've solved this question. So let's check it out. Good. So that's the end of day 10 to day 11 right now. Okay, day 11, we have the winter market sweater search. So at the winter market, Cindy now is browsing the clothing inventory and wants to find all items with sweater in their names. But the challenge is the color and item columns have inconsistent capitalization. Can you write a query to return only the sweater names and their cleaned up colors? Okay, so let's get right in. First of all, let's see what we have in the table. Okay, this shows us our entire table with the item ID, the item name, the color. Now we can see the irregularities in the capitalization, in the color, and the. So I'm going to do a cleanup. So let's do a cleanup. Now I'm using proper because every first letter will be capitalized. That's the uppercase. So I'll do that for the item name and the color. Now let's check this out. Now the question is to bring out items that have sweater in their names. So I'm just to use the where and like. Now for the facts, any item that has sweater in it, I'm going to use the percentage. So I will explain to you what this means. Then also this. Now, if I'm using percentage before, that means this sweater is going to be anywhere around the item name. If there was no percentage here, that means the sweater has to start, this item name has to start with sweater, then any other thing can follow. If I have this like this, then this like this, that means the sweater name has to be at the end. All we are concerned about is having the sweater in the item name. So when we run this returns all the sweater item. So I think this is the solution to that. So the next question we'll move to now is day 12. Okay, this is day 12. It's a North Pole network most active users. So say the North Pole network wants to see who is the most active in the holiday chart each day. Write a query to count how many messages each user sent. Then find the most active user each day. If multiple users tie for first place, return all of them. Right? So we're going to be needing common table expression here. So it's the hard category. If difficulty is hard, so let's first of all, I want to group the message by day and sender. Right, so let's see what we have on the table first. These are the messages. Let's take this up. So we have the message ID, the sender ID, then the when it was sent. Right, so let's check the user. So the user ID and the username, right? Okay, so we're gonna need to get out the group, the day and the sender. So I'll be basically working with the messages, right? Because in messages table we have our sender and our sent at. So firstly, let's get out what we need, that is the day and the sender and the number of message sent. So what this does is that the date helps us to strip off the time. So we just have a date column from here. So I want the date, so I will call it as message date, right? Then we have the sender ID. Then I want to have a count. I want to count everything, the entire table, and that will be the message. I'll call it message count, right? So now we'll need to do a group by the dates and also the sender ID. Now let's check what we have here. Now this let us know each day, each sender per day. As you can see, each sender per day and the number of messages sent. So we're getting there. So I'm going to store this. Okay, let's do something like this. So I will store this whole query inside a city temporary table. So I'm just gonna put it in a bracket. Close the bracket, and I will use says width. Right, so I'll call it daily count as this. So we have daily count as this. So the next thing I want to do, this daily count now, I want to get out the ranking. Take those daily counts and rank the sender within each day, right? So I'm going to need to do a rank over and partition by, right? So let's do that. So I'll have to select. So since I'm getting my value from the daily count, DC, I'm going to call DC daily count dot message dates, right? Daily count dot sender ID, daily count dot. So I'm basically getting what we have there. Dot message count. Now the ranking now, what we're going to add. So I'm just going to add the ranking here. Rank function, rank it over. Now the over, now I'm going to partition it. So I'm going to partition it by the date. Then I would order it by the messages count. So descending, so the highest to the lowest, right? So this is the ranking over the partition, the message date, and the order. I want the order to be from the highest message count to the lowest, right? So this order that currently, it helps us to put the highest message count as rank 1, right? So while the partition by, it helps us to rank every new date, right? So every distinct date we start a new ranking. That's why we have the partition by the date. While the order by will help us to position the highest message count at rank 1. Now this rank here, it helps us to have a tie. If two people have both count of like 20, they both get the rank 1. If they have the same rank of like 20 message counts each, they are both ranked as 1, right? So I'm going to need to store this also in the CTE. Okay, I'm not done. I need to get the from. Okay, before that, I'm going to call this as. Okay, let's bring this to the next line. As activity rank, right? Now from getting it from, remember we're getting it from our daily counts, which is DC. We're getting this value from this daily counts, which is DC. No, I'm going to put. Now let's run this code and see. So we could see that we're returning this. Remember, we're returning this because this is already stored in a table, in a common table expression. So we're returning this: the message date, the sender, the message count, then the activity rank. So we could see for the 20th. Let's take this up and check one after the other. For the 20th, we have 1, 2, 3, 4, 5. So the highest message count is 6, so it's giving rank 1. Second, 2, 2, they're having 2, 2. You could see, while 1, 1 having 4, 4, right? So 21 have the same ranking, 1, 2. This is 1, 1, having 3, 3, so 4, 1, 1. So, and basically that's how it is for all of the table. So let's keep writing our code. Now after this ranking is done, I'm going to need to I'm going to call it ranked as in the bracket here, and close the bracket. Right, before that I need to put a comma here. I need to put a comma there. So the next other thing I want to do is to have a final select where I will join the ranked data to npm user. Right, remember we've been working with the message just since. So I want to join the ranked data that I have to the npm user to get the sender's username, because basically now we have the sender ID. So with the sender ID, I will link it up with sender ID is going to link up with the user ID to get the username. So I'm going to join these two tables to actually get the user that is sending the most message. So by the time I rank the data rank I have, join to the npm user to get the sender username, where the rank activity is 1. That means I'm looking for the highest ranking, which is 1 across each day. I equate to count how many message each user sent, then find the most active user each day. You can see, so the most active user each day is going to be definitely the activity rank of 1 alone. So all the activity rank of 2, 3, 4, 5 and the rest, they wouldn't be included, right? So let's do that now. Now my arrow is my ranked. Remember, my arrow is my ranked. So I want the username also, right? Then the activity rank, and the message count. Then let's add the activity rank. Even though I could still remove it, but let's just add it. Like you can see that we're working with the activity rank of 1 alone. So because of space, I'm just going to bring to the next line. Okay. So I'm getting all of this from the ranked with arrow, right? So I'm going to join with the npm user, right, which is you on, so the user ID, which is an arrow. So user ID, I think is on the U, is equal to arrow.sender ID. Now let's try and return this. Let's see. Now you can see that we have been able to get out the username for all of the table, right? But remember, we want to get out just the activity rank of 1. So let's get to where so let's check this out. Good. So this is our top ranking. Activity rank is 1. Now look at it. The table is not sorted. So let's order by date, from the earliest to the latest. Let's order by date. So you can see from the earliest 20th, this is the most active user. The name 21st, this is the most active user with 6 messages. 22nd, there are 2, Mrs. Klaus and Elf Peppermint. They are both 4 messages. 23rd, there are 3 with 3 messages. So you can see. So we've come to the end of this class. So I believe you've learned basic CTE, joining tables, and writing excellent queries. Check out the previous video for part 1 or day 1 to this 6. Check the comment section for the link to practice these exercises on your own and earn a certificate. So also kindly subscribe to this channel, drop a like, drop a comment, share this video, and stay tuned for the part 3 of this challenge. Thank you.